Oh, hello. I didn't see you there. Today we're going to be talking about penguins. Here, I have a friend I'd like to meet. Say hello. Isn't that adorable? We first met Edgar in the Arctic wilderness, where we studied him for several months. While studying him, we found that Edgar loves to eat and spends most of his time chasing fish. Here's some of our footage. While studying Edgar, we began to notice a pattern. After many weeks of careful calculation, we were able to develop a function that describes Edgar's position as a function of time. This function is f of x equals x cubed minus 12x plus 45x. Using this function, we can determine Edgar's position at any time on our interval 0 to 6.
But what happens if we need to find Edgar's velocity? Do you think you could find Edgar's velocity after 1 second? Feel free to pause the video if you want to figure this out for yourself.
Did you get it? Here, let me explain how we solved this one. First of all, we know that our original function describes Edgar's position. Now, if we realize that velocity is really just another way of saying change in position, it becomes clear that finding velocity is as simple as finding the first derivative. Once we find the derivative, which is 3x squared minus 24x plus 45, all we need to do is plug in 1 to find Edgar's velocity after 1 second. The answer is 24 feet per second. It seems Edgar is a particularly fast penguin. Now that we know how to find velocity, is there a way that we can figure out when Edgar switches directions? Feel free to pause the video again if you'd like to figure this one out yourself. Here's how we solved this one. We know that if Edgar wants to reverse directions, the very point at which he turns, his velocity will have to be 0. We also know that if we can find the velocity by using the first derivative of our function. Therefore, if we set the first derivative of our function equal to 0, we can find the points where Edgar's velocity is 0, and therefore he is turning. Alright. We found the points where Edgar's velocity is equal to 0. But what exactly does that mean? Looks like we have to go to the tape to find out. Alright, let's see that one again. Let's slow the speed down a little this time. It looks as if our function is accurate. Edgar's direction does reverse at the 3-second mark. And then his velocity goes to 0 at the 5-second mark. Let's see if we can figure out what happens after this. First, could you tell me where the igloo is located? Keep in mind, Edgar hit it at the 3-second mark. Finding the coordinates of the igloo should have been simple. All you need to do is plug 3 back into the original function. The result is 54. Now that we know this, it is possible to find out if Edgar hits the igloo again during our interval. Could you figure out if and when he does? Let's see if you got this one. We know that the y-coordinate of the igloo is 54. Therefore, you should set the original function equal to 54. The answers we get from this will tell us when Edgar hits the igloo again. Let's see, we got a 3 and a 6. Looks like Edgar hasn't learned his lesson. Let's see if we're right. Well, looks like he knocked himself out cold. I guess that's the end.